Hey guys, this is Coach Lowe, and we're going over test review. This is for Geometry, Chapter 1. All right, so for exercises 1 through 4, use the figure at the right. What is another name for line L? Line L is here. Remember, when we name lines, we name them with 2 points, so there are several different ways that you could name this line. We could say line DE, line ED, line EF, line FE, or line DF. Or you could use FD. So any of those would work for naming the line on line L on number 1. Number 2, name 3 points in plane P. 3 points in plane P. All right, here is plane P. Being on the plane is in the plane because remember this plane extends in all 4 directions, becoming wider and wider and wider. It's on the back side, if you want to think about it that way, of this plane. That plane kind of shoots through it. So A and B are in plane P. So for number 2, we have points A, B, and C that are in plane P. Number 3, name the intersection. Name the intersection of planes P and N. So where do they meet? Think about 2 pieces of paper, one cutting through the other one. They're going to meet at line AB. They're going to meet at line AB. That's all the points that are on line AB would be in common to both planes. Remember, those planes are extending left, right, up, down. So they would keep going and going. Number 4, name 3 non-coplanar points. So 3 points that are not all in the same plane. We have a lot of different combinations here. I can choose A, B, and E. You could choose D, E, and C. As long as you have 2 points in one plane and 1 in the other. Remember, don't choose A and B because they are in both planes. So they would end up being coplanar with the 3rd point that you choose. So lots of combos there. Lots of choices. We like to have lots of choices, don't we? All right, let's look at number 5. Name the length of segment AB. Notice the units that we are in, centimeters. So we will count in tenths, and it looks like 6 3/10 centimeters. So check your units first, remember on that. Number 6, find the length of DE. If D is between point C and E, so let's go ahead and draw. D is between point CE. We're looking at segment DE, so let's go ahead and do that. So I want segment DE, and it says D is between point C and E. We don't know how far between, we just know it's between. All right, so here's my target. That's the length that I want. All right, we know that CD is 6.5 centimeters. And we know that CE is 13.8. That means all the way across. All right, so I'm missing this piece right here. I know that CD plus DE equals the entire length, so we can subtract to find that. So 13.8 minus 6.5. So subtracting those, 7.3 centimeters. You can also set this up as an equation if you don't like that. We have CD plus DE equals CE, and I can plug in what I know. CD is 6.5. I don't know DE. I'll put an X for it. And CE is 13.8. Piece plus piece equals whole. All right, and you can set it up that way every single time if you want to. All right, number 7. Find the length of XZ. All right, so I want this entire length. We know the expression for the length is 4x plus 3, but we need the number for it. So let's see what we know. We have piece plus piece equals whole. All right, so we can set that up. I know that xy plus yz, the 2 pieces, equals the entire length xz. So I have 8 plus 2x plus 7 equals 4x plus 3. Piece plus piece equals whole. Now I can solve. Let's start with same side. Same side, we're just going to combine like terms. So I have 2x plus 8. 8 and 7 is 15. I don't have anything to combine on the right side, so I'll just leave it. All right, now I'm going to move my x's to the left and my numbers to the right. Doesn't matter which way you decide to do it. So that gives me negative 2x plus 15 equals 3. Instead of scrunching, I'm just going to move this guy right over here. I'm going to subtract 15 from both sides. Negative 2x equals negative 12, or x equals 6. All right, that is not what they asked for, so I'm not finished. They asked for the length of xz. I know that xz is the expression for x plus 3. So when x is 6, 4 times 6 is 24, plus 3 is 27. So the length of xz is 27 centimeters. Now, you could also plug it in here and add 8 to it when you finish. So 2 different ways to do that. All right, number 8, a square has a side length of 2.3 feet, or 2 3/10 feet. What's the area of the square? Area of a square is found just like a rectangle, length times width, or since we know that on a square all the side lengths are the same, we could just do 2.3 squared. We're multiplying it by itself. So however you want to punch that in the calculator. So the area is 2.3 times 2.3, or the area is 2.3 squared. And I got 5 29 thousandths square feet, or feet squared. All right, number 9. A circle has a circumference of 6 centimeters. Find the diameter. All right, so here's my circle. Circumference is the distance all the way around, and they want the diameter. Well, I know that circumference is 2 pi times the radius, or since I have the diameter, circumference is pi times the diameter. So I can go ahead and plug in the circumference because I know that it's 6 and solve for d. So pi is a number, 3.1415, on and on and on. It's irrational. But if you want to, guys, you can just leave it 6 over pi. You don't have to divide that out, and that would be centimeters. All right, keep going. Number 10, find the distance between A and B. All right, so I'm looking for this distance right here. Several ways to do that. Let me get a color here. All right, I can count over and up and use Pythagorean theorem. There's my right triangle. All right, so that means over I have 1, 2, 3, 4, 5, 6, 7, and up I have 1, 2, 3. So I can plug that into c squared equals a squared plus b squared. I don't know c, that's what I'm trying to find. 7 squared for the x plus 3 squared for the y. 49 and 9. So c squared is 58. And to finish, I have to take the square root of both sides. So c is the square root of 58, and you can just leave it just like that. It's fine with me. That's the same as saying x2 minus x1 here. It's the same as putting ordered pairs for these guys and subtracting their x's. Subtracting my x's is how I get this length. Subtracting my y's, my y coordinates, is how I get that length, or you can count. It's totally fine. All right, so let's look at the next one. All right, the next one says find the midpoint of CD. Find the midpoint of CD. All right. All right, so from C to D, I want the middle of that guy right there. All right, so somewhere right in here, midpoint. All right, so I am going to, when I want to find the middle, I want the average, middle. So I'm going to add the coordinates together. X coordinates together, divide by 2, take their average. Add the Y coordinates together, divide by 2, take their average. All right, so let's go ahead and put the points down. C would be starting at 0, 1, 2 to the left and 1 down, so -2, 1, -1. And then putting D on here, 1, 2, 3, 4, 5 across, and 1, 2, 3, 4 down, so 5, -4. All right, so I have -2, -1, and 5, -4. All right, so midpoint. I'm going to add my x's together and divide by 2, add my y's together and divide by 2. All right, so x1, x2. So -2 plus 5 over 2, y1, y2, -1 plus -4 over 2. This is an ordered pair, so we'll just leave it like that. So 3 halves, -2 plus 5 is 3, -1 plus -4 is -5, halves. Leave it as an ordered pair. We just named this point right here. So if I go over 1.5 and then down 2.5, that's the midpoint. And that's exactly what it looks like on my graph. Whoop, whoop. Good job, guys. All right. Let me get this business off of here. Okay, now we are looking for the coordinates of E if C is the midpoint of AE. Okay, so here's my little line. C is the midpoint of AE, so I have a line that goes just like that, where C is in the middle. Okay, so when it's on a graph, you can kind of cheat this a little bit instead of setting it up. If C is the middle, then I go left 1, up 2 to get to A. Guess what I need to do going the other direction? I need to do the opposite, or, I mean, that's kind of how I do it. So I went left 1, up 2 to get to A. I'm going to go right 1, down 2 to get to the other endpoint. Or you can start from A and go down 2, right 1, and then go down 2, right 1. It's slope, isn't it? So you can totally do that. Okay, so let me back up and do that again so you can see. So starting from an endpoint, I'm going, come on, guy. I'm going down 2, right 1 to get to the midpoint, and then, really? Come on. All right, so here, down 2, right 1 to get to the midpoint, and then down 2, right 1 to get to the endpoint. Now we just need to name it. Go back to 0 and name it. I went left 1, down 3. So -1, -3, if you need to rewind that and watch it, do it. The other way that we set that up was we used the midpoint formula, which you guys probably remember from class. We use the midpoint formula on this, and it looks like this. A is, if I start at 0, -3, 1. If I figure out what C is, to get to C, I start at 0. It's -2, -1. And we set that up in our midpoint formula, so it looks like this. X1 is -3. X1 is -3 plus X2 we don't know over 2. Y1 is 1 plus what we don't know divided by 2 is equal to the midpoint which they gave us, -2, -1. Now we're going to set up little equations to solve. So we'll take this guy, which is the x coordinate, and set it equal to the x value and solve. Don't tell anybody, but I like just doing it off the graph when I can. Shh. All right, so to solve this, I'm going to multiply both sides by 2, which gets rid of the 2 off of the bottom. So I have -3 plus x equals -4. Multiply those guys together over here on the right. Add 3 to both sides. And x equals -1, which is exactly what we found right there. All right, on the y coordinates, we'll take this guy and set it equal to this guy. So 1 plus y over 2 equals -1. Same process to get rid of that 2 off the bottom. We'll multiply both sides by 2. So 1 plus y equals -2. Subtracting 1 from both sides of the equation, y is -3, which is exactly what we found right there. So if you don't have a graph, that is how you would do it with the equations. If you do have a graph, then of course you could just count. All right, let's keep going. The vertices of a triangle are located at P00, Q86, R -3,4. So P00, Q86, one, two, three, four, five, six. And R -3,4. They want the perimeter. If I'm finding the perimeter, then we know that I need to find side lengths. So I need the length of RQ, the length of PQ, and the length of PR. Yes? Yes. So we can use distance formula on that. Oops. I don't want to write that there. I just wanted to write a P. All right, so let's do PQ. You can also draw some little triangles with those guys if you want to. I'm just going to bust this out. So x1, y1, x2, y2. So the distance here, square root of x2 minus x1 squared plus y2 minus y1 squared. So I have the square root of 64, right? The square root of 8 squared, which is 64, plus 6 squared, which is 36. So the square root of 100, which is 10. So the distance from P to Q I found to be 10. All right, let's keep going. From Q to P. All right, I'm going to go ahead and, I'm sorry, not Q to P, Q to R. Bam. All right, distance from Q to R. Q is 8, 6, and R is -3, 4. So this is x1, y1, x2, y2. Back to the distance formula. So I have x2 minus x1 squared plus y2 minus y1 squared. So I have -11 squared plus 2, -2 squared, which would be the square root. -11 times -11 is positive 121, and -2 times -2 is a positive 4. So I have the square root of 125, which, by the way, this is 25 times 5. 25 is a perfect square, so I can take the 5 out. So that's 5 square roots of 5. All right. Now for P to R. I'm going to do that over here on this side. From P to R, -3, 4, 0, 0. So distance is the square root of 0 minus a -3 squared plus 0 minus 4 squared. So that would be the square root of -3 squared is 9 plus a -4 squared is 16. I'll go ahead and write that step right here. So 0 minus -3 is -3, and 0 minus 4 is a -4. So that's where I got those. So -3 squared is 9, and -4 squared is 16, which makes the square root of 25, which is 5. So now I have 5 plus 10 plus 5 square roots of 5. All right, you can't add the square root with the other numbers because they don't have square roots. They have to be alike. But I can add the 5 and the 10 together. That's the perimeter, right? Adding all the sides. So 15 plus 5 square roots of 5 is my final answer, and you can just leave it like that. All right, let's go to 14. Find the value of x and y if line segment UV bisects TW. All right, so let's go ahead and mark that. Line segment UV bisects TW. All right, that means if it's a bisector, these two are equal. Bisecting means it cuts something right in half, so I know those two are equal to each other. And I also know that UV is 40. So the length here of UV is 40. Awesome. Okay, so I need X and Y. So how can I get that? Well, first of all, I know that TZ and ZW are equal to each other. So one of the things I could do is possibly set those equal to each other, but look at my variables. I have an X and I have a Y. That's really not going to help right now. However, look at UV. I know that 3y minus 1 and 2y plus 6, if I put those together, that actually gives me the length of UV. So that means UZ plus ZV equals UV. Those are the same. The two sections added together gives me the long one. Well, I know that UZ is 3y minus 1. And I know that from Z to V, they told me is 2y plus 6. And they told me that the length of UV all the way across is 40. So I will go ahead and solve this. Same side, I'm going to combine like terms, so I'm going to add like things together. So 5y plus 5, so I had 3y and 2y, which is 5y, and then I have a minus 1 and a plus 6, which makes plus 5, equals 40. Now I can go across the equal sign, so I'm going to subtract 5 from both sides. So 5y equals 35. So y equals 7. Awesome. All right, so we have found y. Now we need to find x. So back to what we talked about just a minute ago, I know that these two guys are equal to each other. But now I know that y is 7, so I can plug that in right here for y. So 3x minus 2 equals 3 times 7, because y is 7, plus 1. So 3x minus 2 equals 3 times 7 is 21 plus 1. 21 plus 1 is 22. And then I will add 2 to both sides. So I'm going to come right here because I'll be off the screen. So 3x equals 24. And then dividing both sides by 3, x equals 8. So I have finished what they asked. They wanted the value of x and y. X is 8, y is 7. All right, we're almost finished, guys. Getting close, getting close. Over halfway there. On 15, we're supposed to measure angle PQR. You would need a protractor for this, and you would probably need to extend your rays out on both sides. We'd probably need to extend this so that you could measure and extend this one maybe a little bit so you could line it up. But you should get about 64 degrees on that. So if you need to measure that as soon as you come into class, please do so. And that makes that angle acute, right? Acute angle. Oh, it's so cute. Because it's less than 90 degrees. So an acute angle. All right, let's go to the next one. In the figure A, ray EA, so ray EA and ray EB are opposite. Now, since I know that, opposite rays form straight angles, which means that is 180 degrees, and this is 180 degrees. So things that I know right off the bat just from the instructions. So keep that in mind. Keep that in mind. Okay, sorry. All right, and EC bisects FEG. So EC bisects FEG. Man, I got the wrong one. Let's do that again. EC bisects FEG. All right, that means these two guys are equal. So that means angle EFG FC is congruent to or equal in measure to angle CEG. I wrote that backwards, didn't I? Let's get that fixed. FEC. I think I said FEC and then wrote EFC. Angle FEC is congruent to CEG. Vertex needs to be in the middle, so make sure you double check that. All right, so just going to keep that in mind as we work through this. All right. Find the value of x if FEG, so FEG, so there's FEG, equals 82 degrees, and FEC is 5x plus 11. Wait a minute, that's half of that, right? Because we already said that EC was a bisector. Okay, so there are a couple of ways to do this. I know that the measure of this angle is half of 82 because EC is a bisector. It's going to cut FEG right in half. So if that whole thing is 82, that makes this 41, half of 82, which means angle FEC is equal to 42 degrees. Well, they gave me an expression here, and now I can find x because FEC is 5x plus 11. And that's equal to 42. That writing is kind of crazy right there. Let's try that again. All right. 5x plus 11 equals 42. We can solve this. Subtract 11. Did I put 42? Oh man, I put 42. Let's fix that. You guys probably already caught this on the video, but I divided by 2 and I got 41 here, but I wrote down 42 over here. So let's correct that to 41. Thank you if you were already yelling at me on the video. All right, 41 minus 11 is 30. So x is 6. Awesome sauce. All right, number 17. Let me get my writing out of the way so we can kind of focus over here. All right, AED. All right, so let me get this. AED is 16y plus 10. Okay, find the value of y so that ED, segment ED, and AB are perpendicular. That's what that means, perpendicular. So perpendicular segments meet at 90-degree angles. So if I want those two segments to be perpendicular, that means 16y plus 10 has to be equal to 90 degrees. Perpendicular segments, lines, rays, whatever, intersect at 90 degrees. So if I want to force that to be perpendicular, 16y plus 10 has to be 90 degrees. Subtract 10 from both sides. 16y equals 80. And then divide both sides by 16. 80 divided by 16 is 5. So y would have to be 5 for that statement to be true, for segment ED to be perpendicular to segment AB. All right. All right, so let's check out this crazy figure to the right. We're going to use it for these four problems. We need to find the value of y. Find the value of y is the question. All right, so let's just stop and see what we have going on. So first I see some linear pairs, like these two guys will add to be 180. You probably saw that already. These two guys will add to be 180. I don't have an angle measure for angle 1 yet, though. There's some other ones. These three guys would add to be 180. These three guys would add to be 180. So just some things to observe. We also have vertical angles. We know vertical angles are equal in measure. So where these lines are crossing right here, I'm just going to mark those. These guys are vertical angles. They're equal in measure. These guys, that one and these two together, are vertical angles. They're equal in measure. All right, so I think the blue one will help us with finding the value of y, because 72 degrees equals 8y minus 16, and you can solve that. So let's add 16 to both sides. 88 equals 8y, and then we'll divide by 8 to both sides. So y is 11. Y is 11. All right, now we are supposed to find the value of angle 1. So we can use what we just found if we want to, but we also know, let me get this writing off of here. We also know that these two guys are a linear pair. From the vertex, this ray and this ray are opposite, which means they make a straight angle and add to be 180 degrees. So the measure of angle 1 plus 72 degrees equals 180. So solving for that, I'll subtract 72 degrees from both sides. I'm going to drop the degree symbol until I get to the end. So the measure of angle 1 is equal to 108. 108 degrees. All right, and if you don't like writing measure of angle 1 here, if you just want to replace that with x, and then come down here and say the measure of angle 1 equals 108, totally fine. Totally fine. All right, what about the measure of angle 2 now? What about the measure of angle 2? Well, there are some things that we know from this crazy drawing. We know that these three are a linear pair. That's one way to do this. I'm not saying that's the only way, but it's one way to do it. All right, so kind of box this off so we have room to work here. We have 72 degrees plus angle 2, which I'm going to call x for now so that I don't have too many numbers here, plus 40 equals 180. All right, so we can solve from there. And like I said, that's not the only way to do this problem. It's just one way to do this problem. All right, so I can also find x from these two guys. If you want to do it, well, I'll come back to that. Never mind. That's number 21. All right, so let's go here. This is the measure of angle 2. That's what we're looking for, the measure of angle 2. And I just replaced it with x. If you want to use a different letter, since we're going to find x in the next one and that means something else, we could totally do that. We can use, let's use a for angle. Whoops, I don't want to do that. Let's use a for angle. All right, so let's find a. All right, so I'm going to combine like terms. These two guys are on the same side, so 112 plus a equals 180. Then I will subtract 112 from both sides. So a is going to be equal to 68 degrees. A is equal to 68 degrees. That is the measure of angle 2. So I have the measure of angle 2 is 68 degrees. I have the measure of angle 1 is 108 degrees. And I know that y is equal to 11. I'm almost finished. Now we're going to find the value of x. If you're going to ask me why I work from the top right corner over to the left side, I have no answer for you for that. I don't even know. All right, but look, we're right underneath 21, so that's kind of convenient. Okay, so find the value of x. If this is a right angle, this is a straight line, then I know that this also is a right angle because 90 plus 90 is 180 degrees. That means this guy is equal to 90 degrees. So 10x minus 24 equals 90. Adding 24 to both sides, 10x equals 114. So x is, divide both sides by 10, means I'm just going to move the decimal to the left one place, 11.4, not degrees, just 11.4. X is 11.4, so if I put 11.4 in for x here, multiply it by 10, and then subtract 24 from it, I get 90 degrees. So that does check. Awesome. All right, let's keep on going. We are really almost finished now. All right, name the polygon A, B, C, D, E, F by its sides. Okay, so A, B, C, D, E, F is here. So there's 1, 2, 3, 4, 5, 6 sides, which makes this a hexagon. is it convex or concave? Concave means it looks like it has a side smushed in. Or if I trace each of the sides, at some point one of those segments would go through the shape. None of those are going to go through. They're all going to stay outside. So this is convex. Regular or irregular. Regular polygons, all sides are the same length and all angles are the same length, so this is regular. So for polygon ABCDEF, it's a hexagon, it's convex, and it's regular. Find the length of each side of the polygon RST. RST. So that's a triangle. I see that it is convex and it's also regular. The 2 marks tell me that this side is equal to this side is equal to this side, which means if I can just find one side length, I have all 3. If I know that these sides are equal, then I can set those guys equal to each other and solve for y. Then I can plug it back into one of the two, either side RS or side TS, and I can find the length. So let's go ahead and set those equal to each other. We'll add 1 to both sides. So 3y equals 24, equals 2y plus 12. I don't know where that came from. Subtract 2y from both sides, and y equals 12. All right, so that is not the length of the side, though. That's just the value for y. So let's take side RS, for example, 3y minus 1, and let's plug in 12. And then subtract 1. So 3 times 12 is 36, minus 1 is 35. I should get the same number when I plug in 12 right here, and we can just do a quick check. 2 times 12 is 24, plus 11 is 35. So the length of each side of that triangle is 35. All right, let's go on. Number 24, number 24, 2 angles, angle 1 and angle 2 are supplementary. Okay, what does that mean? Supplementary means they add to be 180. So I already know that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. I already know that. That's what that first sentence means. Angle 1 is an acute angle. So I know the measure of angle 1 is less than 90 degrees. All right. So what type of angle is angle 2? Let's just draw a little picture. So here's 90 degrees. Here's the measure of angle 1, somewhere less than 90 degrees. It can even be super close to that right angle. It doesn't matter. I don't know why I wrote angle, but. So there's 90 degrees, a little less than, there's angle 1. All right, so the question is, what do I know about this angle? What type of angle is that? Well, it's going to measure over 90 degrees, which makes it obtuse. So I have a cute little angle over here, angle 1, and angle 2 is obtuse. All right, awesome. All right, last problem. I actually did the bonus also, so we can do that as well. All right, Stephanie wants to transfer the soil from a rectangular pot measuring 4 by 5 by 3 inches into a circular shaped pot. The soil in both pots should be level to the top. What should be the volume of the cylindrical pot? All right, so volume. We're looking for volume, so think about this. I have a box, right, that she put this in. So here's the box, and it's a 4 by 5 by 3. Right, so there's 3, there's 4, and there's 5. So 4 by 5 by 3, not drawn to scale, by the way. So what is the volume of this guy? Well, I have volume of this box, area of the base, multiplied by the height, and it doesn't really, we could have done 4 times 5 times 3, it's totally fine. On the picture I drew, that's just kind of how it came out. So 15 times 4 is 60 cubic inches. All right, this is the volume that I need even for the cylinder, because it said the soil has to be level at the top for both of them. So that's the volume that I need for a cylinder. So let's talk cylinder. Volume of a cylinder. Volume of the cylinder. Area of a base, area of the base multiplied by the height. The base here is pi times the radius squared. All right, so that's this guy right here. So volume when you have a prism or a cylinder is always look at your base and find the area of the base, multiply it by the height. Because you can think about having a gazillion of those kind of stacked on top of each other and that would fill it up. All right, so volume of this cylinder is pi r squared. Stop. Stop. Okay. Sorry, my paper hit the tray on the whiteboard. Pi r squared multiplied by the height. That's the volume of this cylinder. All right, so I know that the volume has to be 60. That's what they told us, that the soil has to be level, so they have to have the same volume. All right, so I have 60 equals pi r squared h. That means my volume has to be 60. If they ask for the radius or the height, we could solve from this right here. So just kind of reminding you on the relationship between the two, we don't have to have this stuff, but we do need to think about if I want this guy level here and I want this guy level here, the volumes have to be the same. All right, so they both have to be 60 cubic inches or 60 inches cubed. All right. Find the dimensions of a rectangle whose length is 3 more than twice its width and has the perimeter of 30 centimeters. Okay, find the dimensions of a rectangle. So I'm going to draw a rectangle. The length is 3 more than twice the width. So I'm going to put an X here. And the length is 3 more than twice the width. So twice the width and then 3 more than that. All right. It has the perimeter of 30 centimeters. Okay, so here's what I know. This is X and this is 2X plus 3. I know perimeter is walking around this bad boy, right? Or I have 2 lengths plus 2 widths. So you can either write this down just like it is, like X plus 2X plus 3 plus X plus 2X plus 3. Or we have 2 widths plus 2 lengths. And it told me that that was 30 centimeters. The perimeter is 30 centimeters. All right, so I have 2x plus, remember distributive property, jump that guy through, 4x plus 6 equals 30. Combine like terms over here, so 6x plus 6 equals 30. Subtract 6 from both sides, so 6x equals 24, or x is 4. All right, so I have the dimensions of one side. All right, so I have the width, so it's a something by 4. What were my centimeters? Units is what I was trying to say. All right, so let's go back up to the length. The length is 3 more than twice the width. So 2 times 4 plus 3. 2 times 4 is 8, plus 3 is 11. So the dimensions are 11 centimeters by 4 centimeters. Bam! All right, guys. Hope you have a great weekend. Be ready to rock it on Monday on your test. This is Coach Lowe, and I'm out.